Polygons. Poly is n-sided closed figure. N-sided closed figure. N-sided closed figure. N should be greater than or equivalent to 3. An n-sided closed figure is called polygon. In a polygon, sides are nothing but straight angles. Sides are nothing but straight lines. Sides are nothing but straight lines. For example, this is a polygon, this is a polygon, this is a polygon, this is a polygon. These are all examples of polygons. N-sided closed figure. N-sided closed figure is called a polygon. N greater than or equivalent to 3. Sides are nothing but straight lines. Sides are nothing but straight lines in a polygon. In a polygon, there are two kinds. Listen carefully, sir. One is a convex polygon. One is a convex polygon and another is a concave polygon. Convex polygon and concave polygon. Convex polygon. Every interior angle is less than 180 degrees. Every interior angle is less than 180 degrees. Concave polygon. At least one interior angle. At least one interior angle. At least one interior angle is greater than 180 degrees. Convex polygon. Convex polygon is a polygon where every interior angle is less than 180 degrees. Concave polygon is a polygon where at least one interior angle is greater than 180 degrees. Another, this is the definition based on angles. Definition based on angles. Definition based on angles. Definition based on angles. There is also another property. Suppose take a figure. Take any 2 points inside the polygon. Take any 2 points inside the polygon. If the line lies completely inside. If the line lies completely inside. If the line lies completely inside. If the line lies completely inside, then the polygon is said to be a convex polygon. Then the polygon is said to be a convex polygon. Take any 2 points. Take any 2 points. If the line lies completely inside, then the polygon is said to be a convex polygon. Suppose if I take a figure like this. Suppose if I take a figure like this. Listen carefully, sir. If there is at least one line which goes outside the boundary of the polygon, then the polygon name is concave polygon. If there is at least one line which can be drawn outside the boundary of the polygon, then the polygon is said to be a concave polygon. Then the polygon is said to be a concave polygon. If you are able to draw at least one line, if you are able to draw at least one line, if you are able to draw at least one line which goes beyond the boundary of the polygon, then the polygon is said to be a concave polygon. Then the polygon is said to be a concave polygon. Convex polygon. Convex polygon, every interior angle is less than 180 degrees. Concave polygon, at least one interior angle is greater than 180 degrees. Every interior angle is less than 180 degrees. Concave polygon, at least minimum if there is one angle which is greater than 180 degrees, then the polygon is said to be a concave polygon. Based upon line also you can define it. Based upon line, if there is at least one line which goes beyond the boundary of the polygon, then it is said to be a concave polygon. I hope this point is clear. As far as Indian aptitude exams are concerned, Indian aptitude entrance exams are concerned. As far as Indian aptitude entrance exams are concerned, we will focus mainly on convex polygons. We will focus mainly on convex polygons. We will focus mainly on convex polygons unless specified otherwise. Unless specified otherwise. If nothing is mentioned, If nothing is mentioned, then the polygon is nothing but a convex polygon. Assume the polygon to be a convex polygon. Assume the polygon. Assume the polygon to be a convex polygon unless specified. Assume the polygon to be a convex polygon unless specified. In Indian aptitude entrance exams, most of the questions are from convex polygons unless specified otherwise. Assume the polygon to be a convex polygon. We will solve almost all problems based upon convex polygon. Number of sides and name of the polygon. Number of sides and name of the polygon. If there are 3 sides, then the name of the polygon is a triangle. If there are 4 sides, then the name of the polygon is quadrilateral. If the name of the polygon is given, you should say how many sides it has got. 5 is called pentagon. 5 is called pentagon. 6 is called hexagon. 6 is called hexagon. 7 is called heptagon. 7 is called heptagon. 8 is called octagon. When we are doing some high level polygon questions, octagon means by default it is 8 sides. 9 is called nanogon. 9 is called nanogon. 10 is called decagon. 10 is called decagon. Very important names of the polygons. Names of the polygons, number of sides and name of the polygon. Then what is a regular polygon? Then what is a regular polygon? Regular polygon. Regular polygon is nothing but it is a convex polygon. It is a convex polygon where all the sides are equal. It is a convex polygon where all the sides are equal. A regular polygon is a convex polygon in which all the sides are equal. If all the sides are equal, all interior angles will also be equal. All interior angles will also be equal. All interior angles will also be equal. A regular polygon is a convex polygon in which all the sides are equal. If all the sides are equal, all interior angles will also be equal. Suppose square is a regular polygon. Square is a regular polygon. Equilateral triangle is a regular polygon. Equilateral triangle is a regular polygon. I hope it is clear. Equilateral triangle is a regular polygon. Equilateral triangle is a regular polygon. Right? Next. First write down, sir. We will solve a lot of problems based upon this. Once we understand the basic definition and the nomenclature of all the questions, then the problems becomes very easier. All interior angles, square and equilateral triangle. Then a new term came, what is an interior angle and exterior angle. We will discuss what is an interior angle and an exterior angle. Then we will discuss, suppose if it is an interior angle. It is an interior angle and it is an exterior angle. Listen carefully, sir. We need to understand what is an interior and an exterior angle. Suppose if it is ABC. ABC. If I extend this line, this is nothing but interior angle. This is nothing but exterior angle. This is nothing but exterior angle. Suppose similarly, if I take an hexagon, this is nothing but an exterior angle. This is nothing but an exterior angle. This is nothing but an interior angle. This is nothing but an interior angle, and this is nothing but an exterior angle. This definition should be very clear. This is an interior angle and E is nothing but an exterior angle. E is nothing but an exterior angle. What is an interior angle and what is an exterior angle? Right. Now, another important point. A n-sided polygon. If there are 3 sides, there will be 3 interior angles and there will be 3 exterior angles. N-sided polygon has n interior angles as well as n exterior angles. Number of sides, number of interior and exterior angles are always equal. Number of sides, number of interior angles and number of exterior angles will always be equal. Suppose for example, if I take a 3 sides A, B, C, these is nothing but E1, these is nothing but E2, these is nothing but E3, these is nothing but I1, these is nothing but I2, these is nothing but I3. In a triangle, there will be 3 interior angles and there will be 3 exterior angles. 3 interior angles and there will be 3 exterior angles. Listen carefully for the next 10 minutes. All the problems are based upon this one. What is the definition of an interior angle? What is the definition of an exterior angle? In an n-sided polygon, there will be n interior angles and n exterior angles. N interior angles and n exterior angles. There will be n interior angles and there will be n exterior angles. Now see here. Sum of all interior angles. Sum of all interior angles. Sum of all interior angles in a convex polygon. Sum of all interior angles in a convex polygon of n sides. It is given by n minus 2 into 180 degrees. N minus 2 into 180 degrees. Sum of all exterior angles in a convex polygon of n sides is given by n minus 2 into 180. How it is formed? Take the example. Suppose if I take a square ABCD, take a point, join the non-adjacent sides. If a four-sided figure has got two triangles. A four-sided figure has got two triangles. Suppose if I take a five-sided figure. Take a point, join the non-adjacent, these non-adjacent and these non-adjacent. 1, 2, 3. Five-sided figure. In a five-sided figure, there are how many triangles? There are total 3 triangles are there. 3 triangles are there. If it is a four-sided figure, I got 2. That means 2 is subtracted because there are 2 adjacent. In a five-sided, there are 3 triangles because there are 2 adjacent. So in an n-sided figure, total sum will be nothing but n minus 2 into triangles. Triangle angle is 180. I hope the proof is clear. Very, very important. Sum of all interior angles in a convex polygon of n sides is given by n minus 2 into 180. Sum of all interior angles in a convex polygon of n sides is given by n minus 2 into 180. I hope this concept is clear. Idea clear, right, sir? Sum of all interior angles in a convex polygon of n sides is given by n minus 2 into 180. For n sides it is n-sided figure. Sum of interior angles is nothing but n minus 2 into 180 degrees. N minus 2 into 180 degrees. Each side is nothing but, for n side it is n minus 2 into 180. Each side it will be n minus 2 into 180 by n. N minus 2 into 180 by n. Each interior angle, very, very important key points. Lot of previous year questions are based upon this point. Each interior angle is given by n minus 2 into 180 by n. N minus 2 into 180 by n. We just now discussed the definition of an interior and an exterior angle. Suppose if it is interior, this will become exterior. So interior plus exterior is nothing but 180. Interior plus exterior is nothing but 180. Interior is nothing but 180n minus 360 by n. So interior is nothing but 180 minus 360 by n. This is interior is nothing but 180 minus exterior. Interior same, 180 same. Exterior is nothing but 360 by n. Very important point. Each exterior angle in a convex polygon, each exterior angle in a convex polygon of n sides. Each exterior angle in a convex polygon of n sides is called as is given by 360 by n. So sum of all exterior angles, sum of all exterior angles, sum of all exterior angles, sum of all exterior angles in a convex polygon, sum of all exterior angles in a convex polygon of n sides is always 360. Sum of all exterior angles in a convex polygon of n sides is nothing but 360. Very important point. Sum of all exterior angles. Sum of all exterior angles is nothing but 360 degrees. It is independent of the number of sides. It is independent of the number of sides. It is independent of the number of sides. Sum of all exterior angles. Sum of all exterior angles in a convex polygon of n sides is always 360 degrees. All these are very important. Each exterior angle is given by n minus 2 into 180 by n. Interior plus exterior is always 180 degrees. Each exterior angle in a convex polygon of n sides is nothing but 360 by n. In sum of all interior angles, each interior angle. Sum of all exterior angle, each exterior angle. These four key points are very important. Another, the most commonly asked question, number of diagonals. Number of diagonals in a convex polygon. Number of diagonals in a convex polygon of n sides. Number of diagonals in a convex polygon of n sides is nc2 minus n. Number of convex polygon of n sides is nc2 minus n. Why nc2 minus 1? Proof. Suppose if there are 4 points are there, to draw a line, I require, to draw a line I need, to draw a line I need 2 points. To draw a line I need 2 points. So out of 4 points I will select 2 points. One line, second line, third line, fourth line, fifth line, sixth line. So to number of straight lines is nothing but nc2. Adjacent are nothing but, for 4 it is 4. So there will be n adjacent. These is nothing but the remaining diagonals. These is nothing but the remaining diagonals. nc2 minus n. nc2 minus n. What is nc2? nc2 is nothing but the total number of straight lines. nc2 is nothing but the total number of straight lines. N is nothing but the adjacent sides. From total if I subtract adjacent, from total if I subtract adjacent, from total if I subtract adjacent, I will get the, from total if I subtract adjacent, I will get the diagonals nc2 minus n, which is nothing but n into n minus 3 by 2. N into n minus 3 by 2. If you solve it, you will get n into n minus 3 by 2. Extremely important concept. Sum of all exterior angles is given by n minus 2 into 180. Each interior angle is given by n minus 2 by n into 180. So each exterior angle of n sides is 360 by n. Sum of all exterior angles is given by 360 degrees. Number of diagonals in a convex. Number of diagonals in a convex polygon of n sides is nothing but, number of diagonals in a convex polygon of n sides is nothing but n into n minus 3 by 2. Few facts about regular polygons. Important facts about regular polygons. Facts about regular polygons. Facts about regular polygons. Listen carefully. Here we will write the name of the polygon. Name of the polygon. We'll write exterior angle. Always our point of reference will be exterior angle. From exterior angle, finding interior angle is very easy. Then it is interior angle. Then it is number of diagonals. From this table, so many questions from the past years came. Number of polygon, exterior angle, interior angle and diagonal. Name of the polygon, exterior angle, interior angle and diagonal. Suppose if it is a triangle. It is a triangle. Triangle means number of sides are 3. So each exterior angle is nothing but 360 by 3, which is 120. Interior plus exterior is 180. Interior plus exterior is 180. So interior will be 60. The number of diagonals will be 0, which is nothing but 3 into 3 minus 3 by 2. Next, important things, the questions which came in exams that we will discuss. Next, it is quadrilateral. Quadrilateral is nothing but 4. 360 by 4 is nothing but 90. 180 minus 90 is 90. So it is 4 into 4 minus 3 by 2, which is nothing but 2. This is for quadrilateral. Suppose if it is for pentagon. Pentagon means number of sides are 5. 360 by 5 is 72. 180 minus 72, it is 108. 5 into 5 minus 3, 2 by 2, which is nothing but 5. Pentagon. Next it is hexagon. Hexagon. Hexagon it is nothing but 6. 360 by 6 is 60. 180 minus 60, 120. 6 into 6 minus 3 by 2. 3 3s are 9. Last one. These are all some of the questions which came. Octagon is nothing but 8. 360 by 8 is nothing but 45. So 180 minus 45, 135. 8 into 8 minus 3, 5 by 2, which is nothing but 20. 20. I hope it is clear. From these a lot of questions came, sir. Some facts about regular polygons. What is the name of the polygon? Each exterior angle how much? Each interior angle how much? Each exterior angle and each interior angle. Now, most popular polygons are, the most commonly asked questions are, most popular polygons are, the first one is a triangle. First one is a triangle and the next one is quadrilateral. Next one is quadrilateral and the last one is regular hexagon. Regular hexagon. Regular hexagon. Regular hexagon. Hexagon means total 6 sides will be there. 6 sides will be there. In this regular hexagon, if you see hexagon, what is the interior angle? 180 degrees. From center, if I join all, total 6 equilateral triangles I will form. So it is 60 degrees. It is 6 angles that are formed here. Area of regular hexagon. Area of regular hexagon is nothing but 6 into area of equilateral triangle root 3 by 4 a square. 3 root 3 by 2 a square. Area of regular hexagon is given by this notation. There are 6 equilateral triangles that are formed in a regular hexagon. This is a theory. Now we will start with the problems right after this. I hope this theory is clear. How many sides? A regular polygon. How many sides? A regular polygon has whose interior angle, whose each interior angle, whose each interior angle is nothing but 160 degrees, whose each interior angle is 160 degrees. How many sides a regular polygon has whose each interior angle is 160 degrees? Interior plus exterior is nothing but 180 degrees. exterior is nothing but 180 minus 160, 20. Exterior is 360 by n. So exterior angle is given by 360 by n. N is nothing but 360 by 20. Answer is 18. Answer is 18. I hope the idea is clear. Number of sides for an interior angle 160 degrees is nothing but interior plus exterior is 180, exterior is 20, exterior is 360 by n. N is 360 by 20. Answer is 18. Next, second question. One by one, we will increase the level of difficulty. Second question. How many integral values? How many integral values? How many integral values interior angle takes? How many integral values interior angles takes? How many integral values interior angle takes in a convex polygon? In a convex polygon, how many integral values an interior angle takes in a convex polygon? Another beautiful question, sir. Each interior angle is given by n minus 2 into 180 by n minus 2 by n into 180. This is nothing but 180 n minus 360 by n. So this is nothing but 180 minus 360 by n. 360 by n. This is nothing but each interior angle. This is nothing but each interior angle. Now, what is the question? Question is how many integral values interior angle takes. Each interior angle, how many integral values it will take. Interior angle takes integral value. This is an integer 360 by n. That means n should be a factor of 360. N should be a factor of 360. N should be a factor of 360. If n is a factor of 360, this is nothing but 360 is 2 cube into 3 square into 5 power 1. In prime basis, 8 9s are 72, 72 5s are 360. This is 4, this is 3, this is 2. What are that 4, 3 and 2? 2 cube means all the powers of 2 will take 2 power 0, 2 power 1, 2 power 2, 2 power 3. 3 power 0, 3 power 1, 3 power 2. 5 power 0, 5 power 1. 24 values I will get, but I already discussed that in a polygon, n is greater than or equivalent to 3. N is greater than or equivalent to 3. N value in 24, n value 1 cannot be possible, n value 2 cannot be possible. So total answer is 22. Total answer is 22. I hope it is clear, right, sir? How many integral values interior angle can take? Each interior angle is given by n minus 2 by n into 180. N minus 2 into 180 by n is 180 n minus 360. So each interior angle is given by 180 minus 360 by n. Interior angle should be an integer. That means n should be a factor of 360. N should be a factor of 360. So 360 is 2 cube into 3 square into 5 power 1. 4 into 3 into 2, 24. In the 24, n value not possible, n value 2, 1 not possible, n value 2 not possible. So 24, 2 values are not possible. 2 values are not possible. I hope it is clear. The largest number of acute angles that a convex hexagon can have. Largest number of acute angles that a convex hexagon can have. Largest number of acute angles that a convex hexagon can have. Largest number of acute angles the convex hexagon can have. There are important keywords. What is an acute angle and what is a convex hexagon? Acute angle. Acute angle will be 0 less than theta less than 90. Obtuse angle will be obtuse angle will be 90 less than theta less than 180. Now see, interior plus exterior is 180. Exterior is 180 minus interior. Exterior is 180 minus interior. If the interior angle is acute, exterior angle will be obtuse. Exterior angle will be obtuse. Are you all with me? Because interior it is preceded by negative. If interior is obtuse, if the interior is obtuse, exterior will be acute. If the interior is acute, exterior is obtuse. If the interior is acute, exterior will be obtuse. Acute angle will be 0 less than theta less than 90. Obtuse angle will be 90 less than theta less than 180. Now think logically. Sum of all exterior angles. Sum of all exterior angles. Sum of all exterior angles in a convex polygon. Sum of all exterior angles in a convex polygon of n sides, it is nothing but 360 degrees. Already we discussed sum of all exterior angles in a convex polygon of n sides is 360. If the interior is acute, exterior will be obtuse. Obtuse is nothing but 90 less than theta less than 180. Theta is greater than 90. Even if I take 90.1, if I take 4, I will get 360.4. So it cannot be 90 point something. 90 point something into 4. That means the value is greater than 360. 90 point something into 4. The value will be greater than 360. That means maximum obtuse it can have is only 3. If I take 4, I am getting greater than 360. If exterior obtuse is 3, interior acute will also be 3. Interior acute will also be 3. I hope the idea is clear. I hope the idea is clear. Idea clear, right, sir? Any doubts in this question? Please ask me in case if you got any doubts. You got any doubts? Please ask me. This is a very, very beautiful question, sir. If acute angle lies from 0 to 90, obtuse angle lies from 90 to 180. Interior plus exterior is 180. If interior plus exterior is 180, exterior is 180 minus interior. Interior acute, exterior will be obtuse because it is 180 minus 60 will become 120. 180 minus 30 will become 150. 180 minus 40 will become 140. If the interior is acute, exterior will be obtuse. So sum of all exterior angles is nothing but 360. So even obtuse angle exterior if I take 90 less than theta less than 180, theta is greater than 90. 90 plus something into 4, 360 by 4. Answer is exceeding 360. So it cannot have 4. Maximum how many it can have? 3. So maximum if it has got 3. Maximum if it has got 3. Maximum if it has got 3. I hope it is clear. Right? Again I am explaining Priya for you. Now just read the question once again. Question. What is that question? Question is, I'll show you the question once so that it will be clear. Question is the largest number of acute angles the convex hexagon have. He is asking for the acute angle. Acute angle should be an interior. Interior plus exterior is 180. Exterior is nothing but 180 minus interior. If interior is acute, exterior will be obtuse. If interior is acute, exterior will be obtuse. So, if interior has to be acute, exterior has to be obtuse. So obtuse angle means 90 less than theta less than 180. Theta will be greater than 90. So theta is greater than 90. That means 90.1 into 4, it is 360.4. So it has to be greater than 4. It has to be greater than or equivalent to 4 to exceed 360. So the maximum it will be 3. Exterior obtuse is 3. Interior acute is also 3. Interior acute is also 3. I hope Priya right now it is clear to you. Next question, sir. The interior angles. The interior angles of a polygon. The interior angles of a polygon are in AP. Interior angles of a polygon are in AP. Arithmetic progression. If the smallest angle is 100 degrees, if the smallest angle is 100 degrees, smallest angle is 100 degrees, common difference is 4 degrees, common difference is 4 degrees. Find the number of sides. Another beautiful question, sir. Find the number of sides. Interior angles of a convex polygon are in AP. Smallest angle is 100 degrees. Common difference is 4 degrees. Find the number of sides. Find the number of sides. Find the number of sides. Now if you see here, interior plus exterior is nothing but 180. Interior plus exterior is 180. Exterior is nothing but 180 minus interior. First point, interior angles of a polygons are in AP. Interior angles of a polygons are in AP. If interior angles are in AP, if you add, if you subtract, exterior angles will also be in AP. If the interior angles are in AP, exterior angles are also in AP. So exterior largest 180 minus 100 is nothing but 80 degrees. Exterior largest is 80. If the interior are in AP, obviously exterior will also be in AP, because 1, 2, 3 are in AP, minus 1, minus 1, minus 2, minus 3 are in also in AP. 180 minus 1, 180 minus 2, 180 minus 3 are also in AP. Exterior largest is also 80. Common difference is 4. So these 80. Difference is 4. 76. 72. And another key point which we know is sum of all exterior angles. Sum of all exterior angles. It is nothing but 360 degrees. Stop exactly at a point 360. It is 68 and it is 64. 80, 76, 72, 68, 64. 60 plus 60, 120 plus 12, 132. These is nothing but 148. These is nothing but 80. 280 plus 80, 360. Yes, sum is 360. How many exterior angles I got? 5 exterior angles I got. How many interior angles also I will have? 5 interior angles also I will have. 5 interior angles also I will have. I hope it is clear. Fifth one, please write down this question. There are two regular polygons. There are two regular polygons. There are two regular polygons. There are two regular polygons with the number of sides. With the number of sides in the ratio. With the number of sides in the ratio 4:5. 4:5. And the interior angles are also in the ratio. And interior angles are also in the ratio. 25:26. Another competitive examination question. 25:26. Find the number of sides of the polygon. Find the number of sides in the first polygon. Find the number of sides in the first polygon. Options are 8, 10, next is 12, next is 15. There are two regular polygons with the number of sides in the ratio 4:5, and interior angles are also in the ratio 25:26 number of sides. There are two polygons. First polygon first polygon and the next one is second polygon. They are in the ratio 4:5. We require number of sides in the first polygon. 4:5 means it is 4k and it is 5k. Answer has to be a multiple of 4. So these are all out. Suppose if I take 12, if I take 12, 4 threes are 12, 5 threes are 15. 5 threes are 15. What is the relationship between exterior and interior? 360 by n. So exterior is nothing but 360 by 12, 30. Interior will be 150. Interior will be 150. Exterior will be 360 by n, which is nothing but 24. Interior will be 180 minus 24, which is 156. Which is 156. 625s are 150. 626 are 156. So it is in the ratio 25:26. It is there in the ratio 25:26. Answer is nothing but 12. I hope this idea is clear. I hope the idea is clear. I hope the idea is clear. Right? So again I am repeating. So there are two regular polygons with the number of sides in the ratio 4:5 and interior angles are also in the ratio 25:26. So this is nothing but 4k, this is nothing but 5k. 4k and 5k. If it is 4k and 5k, first polygon will be a number of sides will be a multiple of 4. So I assumed that option C is right. 4k is 12, k value 3. 5 into 3 is 15. So if I take 12, what is an exterior angle? Exterior angle is 360 by n. 360 by 12 is 30. Exterior is 30. Interior is 180 minus 30, 150. Exterior is 360 by 15, 24. Interior is 180 minus 24, 156. 150 and 156. Check it out whether they are there in the ratio 25:26. Yes. So answer is 25:26. 25:26. Idea clear, right, sir? Now let me increase the clear. Next, one more question based upon this same concept. Answer is nothing but 25:26, which is satisfying the question. Answer is 12. Next, sixth one. Number of sides. Number of sides into regular polygons. Number of sides into regular polygons are in the ratio 1:2. Difference between their exterior angles. Difference between their exterior angles is 45 degrees. Difference between their exterior angle is 45 degrees. Number of sides in one of those polygons. Number of sides in one of those polygons. Number of sides in one of those polygons. Options if I take 5, 6, 7 and 8. 5, 6, 7 and 8. Number of sides in regular polygon is 1:2. 1:2. Difference between their exterior angles. Again, the best way to solve is, right? So best way to solve it is by using answer options. Suppose if I take number of sides in the regular polygon. Suppose if I take 5. If I take 5, next one it will be 10. What is an exterior angle? 360 by 5, 72. Next is 360 by 10, 36. Difference is nothing but 36 degrees. So these are not possible. If I take 6, 360 by 6. Next it will become 360 by 12. 360 by 12. 360 by 12. This is 60 degrees. This is nothing but 30 degrees. 60 minus 30 is 30 degrees. I hope it is clear, right, sir? I hope it is clear. right? Suppose if I take last option D, if I take 2 as 8, this will become 4. 360 by 4 minus 360 by 8. This is nothing but 90 minus 45, which is 45 degrees. So answer is nothing but 8. One is to take 4k and 5k and try to solve these by using answer options approach. These by using answer options approach. I hope the idea is clear. Fifth one, I hope the idea is clear. If there is an octagon, if there is an octagon with 4 interior angles as acute angles, 4 interior angles as acute angles, 4 interior angles as acute angles, then it is another beautiful question, sir. Then it is necessarily convex, necessarily convex, necessarily concave, necessarily concave, regular octagon, regular octagon. D, it is none of this. D, it is none of this. If there is an octagon, if there is an octagon with 4 interior angles as acute angles, then it is necessarily convex, necessarily concave, regular octagon, and none of this. If there is an octagon, if nothing is specified, we are discussing convex polygon. So this is a convex polygon. Convex polygon, what is sum of all interior angles? Sum of all interior angles. Sum of all interior angles is given by n minus 2 into 180. So octagon is nothing but n equivalent to 8. Octagon is nothing but n equivalent to 8. 8 minus 2 is 6. 6 into 180 is 1080. Total 8 angles, it is 1080. With 4 interior angles as acute angles. Acute angle. Acute angle means 0 less than theta less than 90. There are 4 angles. So 0 less than theta 1 to theta 4 less than 360. 4 angles sum is less than 360. 4 angles sum is 4 angles sum is less than 360. Total angle is nothing but 1080. Remaining 4 interior angles should be greater than 720. Remaining 4 interior angle is greater than 720. One interior angle is greater than 180. One interior angle is greater than 180. If interior angle is greater than 180, then the polygon is said to be a concave polygon. One interior angle it is greater than 180 degrees, then the polygon is said to be a concave polygon. I hope it is clear. I hope it is clear. If there is an octagon with 4 interior angles as acute angles, step number 1, it is an acute angle. Acute angle. Acute is nothing but n equivalent to 8. Convex polygon, sum of all interior angles is n minus 2 into 180. 8 minus 2 is 6. 6 into 180 is 1080. So 6. The total sum of all interior angles is 1080. 4 angles sum is less than 360. 4 angles sum is less than 360. Remaining 4 angles sum is greater than 720. Erranna for you. Total first step, it is an octagon. Octagon means n equivalent to 8. Sum of all interior angles. Sum of all interior angles is nothing but 8 minus 2 into 180. 6 into 180 is 1080. Total 8 angles are there. Total 8 angles are there. Out of which 4 angles. 4 angles it is nothing but less than 360, because every angle is nothing but an acute angle. If 4 angles is less than 360, the remaining 4 angles should be greater than 720. Remaining 4 angle is greater than 720. One angle is greater than 180. If one angle is greater than 180, then the question is, it should be number necessarily concave. It should be necessarily concave. I hope it is clear. It should be necessarily concave. It should be necessarily concave. Seventh question. Seventh one. If the sum of all angles, if the sum of all angles except, this is a beautiful question, sir. Sum of all angles except one of a convex polygon, except one of a convex polygon, it is 2190 degrees. It is 2190 degrees. Number of sides of the polygon, number of sides of the polygon, number of sides of the polygon must be. Very, very good question, sir. 7th and 8th. It is 13. Next is 15. 15. Next will be 17. Next will be 19. Next will be 21. 13, 15, 17, 19 and 21. If the sum of all the angles except one of a convex polygon is 2190 degrees, number of sides of the polygon must be. Number of sides of the polygon must be. Whenever you are solving a question, ensure that you go step by step. Sum of all interior angles. Sum of all interior angles is n minus 2 into 180 degrees. N minus 2 into 180. Except 1, I don't know. So it is minus x. It is nothing but 2190 degrees. Because it is a convex polygon, x should lie from 0 to 180. I hope it is clear. X should lie from 0 to 180. I hope this equation is clear. N minus 2 into 180 minus x is 2190. Sum of all angles except one in a convex polygon. All angles is n minus 2 into 180 except one is minus x. Total is 2190. Now we will apply digital sum. 180 digital sum is 9. 9 minus something is 9. This is nothing but 2 plus 1 3. 3 plus 9 12. 12 is 3. So this is nothing but digital sum should be 6. Digital sum should be 6. First key point. Second, this is divisible by 10. This 180 is divisible by 10. 2190 is also divisible by 10. Divisible by 10, divisible by 10. This should be divisible by 10. So here 0 will come. Here 0 will come. Now if you see here, 60. 60 means this could be 60. Or it could be 150. Or it could be 240. Or it could be 330 and so on. But because it is a convex polygon, angle will lie from 0 to 180. So this is not possible. This is not possible. This is also not possible because 180 is divisible by 4, 60 is divisible by 4, 90 is not divisible by 4. 180 is divisible by 4, 60 is divisible by 4, 90 is not divisible by 4. So what is the only answer? 150. Very logically you can solve it. So n minus 2 into 180 minus 150, which is nothing but 2190. N minus 2 into 180, which is nothing but 2340. 0 0 cancel. 9 2s are 9 26 are 2 1s are 2 13s are. N minus 2 is 13. N is 15. N is 15. Please make a star mark on this question. Sum of all angles except one in a convex polygon. Sum of all angles is n minus 2 into 180 except one. It is minus x. It is nothing but 2190. 180 digital sum is 9. This digital sum is 3. So x digital sum should be 6. So that is the reason all the numbers will have digital sum 6. 180 is divisible by 10. 2190 is divisible by 10. Where we should assume IPSIT, right? Digital sum should be 6 beta. So answer is 15. I hope the logic is clear. We will solve one more question similarly. I hope the logic is clear. One more question we will solve directly. You will get the answer. Eighth one. The sum of all but one of the interior angles. The sum of all but one of the interior angles. Sum of all but one of the interior angles of a convex polygon. It is 2570 degrees. 2570 degrees. Remaining angle is options 90, 105, 120, 130 and 140. By looking at a question itself, you can get the answer. Sum of all but one of the convex interior angle of a convex polygon. Now see, sum of all the angles is n minus 2 into 180, except sum of all but one. The but one means except. Minus x is nothing but 2570 degrees. Again the same concept. Digital sum. 180 digital sum is 9. This digital sum is 5. This digital sum should be 4. Digital sum 9, digital sum 5. It should be 4. First point. Second point. This is divisible by 10. This is divisible by 10. 2570 also divisible by 10. X should be divisible by 10. So it could be 40. Next is 130. Next is 220 and so on. 40, 130, 220 and so on. This is divisible by 4. 40 is divisible by 4. 70 is not divisible by 4. Because it is a convex polygon, all the angles should be greater than 180. So answer is nothing but 130 degrees. Answer is nothing but 130 degrees. I hope the idea is clear.
You can learn any subject, anywhere, any place and on the go. Come, let us go the other way in learning. Download our revolutionary app for free.